Hi, today I'm going to be working on the May 2024 Paper 2 Variant 3 Math paper. Before we start, I really hope you can subscribe to my channel. Question 1 says to write the number 2,002,002 in figures. So for this, there are three parts. You have the number 2 million, you have the number 2000, and you have the number 2. So to find the number 2,002,002 in figures, you just add all of these three parts individually. And this produces 2002,002. And this is your final answer, 2,002,002. Question 2 says to put one pair of brackets into this calculation to make it correct. For this, there's no one way of finding the correct answer, and it's mainly just trial and error of trying to put the brackets in random places until you get the correct answer. In this case, the bracket goes over here. Since BODMAS occurs, right, where for any operations, the first operation that's carried out is brackets, i.e. whatever's inside a bracket before any division, multiplication, addition, or subtraction. Therefore, 4 times 3 minus 9 is the first operation being carried out, and this produces 12 minus 9, since within the bracket multiplication occurs before subtraction, and this is equal to 3. So 5 minus 3 minus 2 is equal to 0. Therefore, the bracket should go in this position because it's correct. Question 3 says to simplify 7x minus 8y minus x minus y. So for this, let's first group all the terms with the same variable. So on one side we have 7x minus 1x. I'm writing minus 1x because minus x is just equal to minus 1x. And on the other side we have minus 8y minus 1y. So if you have two terms which have the same variable, for example ax plus bx, this can be rewritten as a plus b grouped times x, because x will act independently on both a and b. So it will be a times x plus b times x, which produces ax plus bx, which is equal to the original value itself. Therefore, using this principle, let me just erase this once. We can rewrite 7x minus 1x as 7 minus 1x plus minus 8 minus 1y, and this is equal to 6x minus 9y, and this is your answer for question 3. Question 4 says that the base of a cuboid measures 10 centimeters by 7 centimeters and the volume of a cuboid is 280 centimeter cube. Calculate the height of the cuboid. So the volume of the cuboid is equal to the base area times the height, and this is always true for any cuboid, which means that you have to memorize this formula before the exam. This is because if we try to imagine a cuboid as a series of multiple base areas stacked on top of each other, when these all are combined, they produce this kind of cuboid, right? So the volume is the sum of all these individual base areas, and the number of base areas is essentially the height itself, which shows how many base areas there are. So there can be 1, 2, 3, and so forth. So the volume is equal to the base area times the height, and the base area in turn is equal to the length times the breadth, and we have those two measurements, since that's equal to 10 centimeters by 7 centimeters as shown in the question here. So this times height is equal to the volume. For now, since the volume is written as 280, I'll write that on the left hand side. 280 is equal to 10 times 7 times h, which is 70h. Therefore, h is equal to 280 divided by 70, which is equal to 4. This is your answer for question 4. Funny coincidence. Question 5 says that in a city, the odds that it will rain today is 0.15, and the question is asking you to find the odds that it will not rain in the city today. Now, since there are two events, either it raining or not raining, and these are the only two possible events, and the sum of all possible events is equal to 1, this means that the odds of it not raining in the city is the total 1 minus the odds of it raining in the city minus 0.15. This is equal to 0.85. This is because if we add the odds of it not raining, 0.85, with the odds of it raining, 0.15, this represents all the possible events. Since there are only two possible events, either it rains or it doesn't rain, nothing else could occur. And since they both add up to 1, this answer is right. Question 6 has to factorize completely 4x square y minus 5x y square. So if we break this down, sorry, I wrote that blue. If you break this down into 4 times x times y minus 5 times x times y times y, I'm writing y twice for the right term and x twice for the left term because x is squared in the left term and y is squared in the right term, which means that it's being multiplied with itself once. So since there are two common factors, you have 1x and 1y, this means that we can move these two common factors to one side, xy times, and what's left in the left hand side is 4 and x. So 4x minus, because this is the minus over here, and then on the right hand side what's left is 5y. Therefore this is your answer for question 6, xy times 4x minus 5y. This is because this term acts on these two independently. So this is equal to xy times 4x minus xy times 5x. So the answer is xy 4x minus 5y. So for question 7, the scale of a map is 1:40,000. On the map, the distance between two villages is 37 centimeters. Calculate the actual distance between two villages and give your answer in kilometers. So this question is saying that 1 centimeter on the map is equal to 40,000 centimeters in real life. And the question is also saying that the distance between two villages on the map is 37 centimeters, which means that if you multiply both sides by 37, this means that 37 centimeters, which is the representation of the distance between the two cities on the map, is equal to 40,000 times 37 centimeters in real life. And this is equal to 1.48 million. So 1,480,000 centimeters. So this is your actual distance. I'll abbreviate this as AD in centimeters. 1.48 times 10 to the power of 6 centimeters. Now the AD in meters is equal to 1.48 times 10 to the power of 6 divided by 10 to the power of 2. Since anything in centimeters divided by 100, i.e. 10 squared, is equal to the answer in meters. So this is equal to 14,800. But the question is asking for the answer in kilometers, which means that the AD in kilometers is equal to 14,800, which is the AD in meters, divided by 1,000. Since anything in meters divided by 1,000 gives you the answer in kilometers. And this is equal to 14.8 kilometers. Therefore, this is your final answer, 14.8 kilometers. Question 8 says that without using a calculator, work out 3 divided by 7 minus 1 divided by 14. And you must show all your working and give your answer as a fraction in its simplest form. This is the very key phrase, in its simplest form. So, as you can see, the two denominators are 7 and 14. So the LCM of 7 and 14 is just 14 because 7 is a factor of 14, which means that 7 multiplied by 2 itself produces 14 and 14 multiplied by 1 produces 14. Therefore, if you multiply the two fractions to make the denominator common, so in this case the left fraction 3 by 7, if we multiply both the numerator and denominator by 2 and we subtract this by 1 by 14, we can just multiply this by 1, which I means nothing because anything multiplied by 1 is just itself. This is equal to 3 times 2, which is 6, divided by 7 times 2, which is 14, minus 1 by 14. This is equal to 5 by 14. And the question asks for you to give your answer in its simplest form. And since 5 by 14 is the simplest form, it cannot be broken down further. Since 5 is a prime number and 14 does not have 5 as a factor, this means that the final answer is equal to 5 by 14. Question 9 says that a diagram shows a right angle triangle and to calculate AB. So in this question, there's a hypotenuse, we have the opposite and we have the adjacent. The hypotenuse is the side that's opposite to the right angle and it's always the longest side of the right angle triangle. The opposite is the side that's opposite to the angle that's being measured, so in this case 37 degrees. And the adjacent is the non-hypotenuse side that's touching the angle, i.e. it produces the angle with the hypotenuse. So with this in mind, since we have the hypotenuse already, which is 8 centimeters. We have the angle, and the question is asking for AB, which is the adjacent. This means that if we use SOHCAHTOA for help, SOHCAHTOA. By the way, this abbreviation is important for any trigonometry related questions, so you must memorize this before the exam, unless you already know it. Okay, I think my iPad just corrected SOHCAHTOA. 1 second. SOHCAHTOA. So since we have the since we have the hypotenuse and the angle, and we want the adjacent, this means that we use. Okay, 1 second. Sorry, my iPad again corrected it. Let me just there we go. So we have the adjacent and we have the hypotenuse and the angle, and we need the adjacent. Therefore, we use because has the cos, which is basically means the angle. We have the hypotenuse and we want the adjacent, and these are the three variables we concern ourselves with, which are all in So just means that cos angle is equal to the adjacent divided by the hypotenuse, and since the angle is equal to 37 degrees and the hypotenuse is 8 centimeters, if you multiply both sides by 8, this cancels off with the denominator and means that the adjacent is equal to 8 cos 37 degrees, and this when rounded is equal to 6.39 when rounded to 3SF. Therefore, the final answer is 6.39. Question 10 says to find the gradient of the line joining the points -2,7 and 3,1. So if we treat this point as point 1 and this point is point 2, this means that this coordinate is x1, this coordinate is y1, this coordinate is x2, and this coordinate is y2. And the formula for any gradient Im is equal to y2 minus y1 by x2 minus x1. This is equal to y2, which is 1, minus y1, which is 7, divided by x2, which is 3, minus x1, which is minus 2. This means that the answer is equal to minus 6 divided by positive 5. Since 3 minus minus 2 is equal to 3 plus 2. Since two minuses make a positive. And minus 6 by 5 is your final answer. Note that you can take any of these two terms, like any of these 2 points as point 1 and point 2. So even if you swap these 2 points around, I make 3.1 instead and make minus 27.2 instead, the answer remains the same nonetheless. 1 second. There we go. Question 11 says to solve the simultaneous equations, 5t minus 2w is equal to 19 and 3t plus 2w is equal to 5. Since the question is only 2 marks, this means that you have to try to think about the answer creatively. As we can see, the coefficients of w are the same, i.e. -2 and +2, which means that if we add these two equations together, this means that 5t plus 3t is equal to 8t, minus 2w plus 2w is equal to 0w, is equal to 19 plus 5, which is 24. And 0w means nothing because anything times 0 is equal to 0. So this cancels off. 8t is equal to 24. Therefore, t is equal to 24 divided by 8, which is 3. Now this is your answer for half the question, since we have one variable solved so far. Now, with this value of t, we can take any one of these two equations. So either equation 1 or equation 2. For now, I'll take 2. 3t plus 2w is equal to 5. We can sub in the value of t into t over here. So 3 times 3, since the value of t is 3, plus 2w is equal to 5. So 2w is equal to 5 minus 9, since 3 times 3 is equal to 9. And if we move it to this side, this means that we do minus 3 times 3, which is 5 minus 9. And w is equal to 5 minus 9 divided by 2, which is equal to minus 4 divided by 2, which is equal to minus 2. And this is your final answer for the question. Question 12a says to simplify 32 times g to the power of 16 divided by 16 times g to the power of 8. So if you break this down, this is equal to 32 times g by 16 divided by 16 times g by 8. This means that since both sides have multiplication, this means that we can just cancel off terms easily. So for example, if we take 32 and 16, since 32 is just 16 times 2, this means that 32 divided by 16 is 2. And so since both the numerator and denominator are just multiplication operations, this means that we can easily just cancel off terms like that. So 16 gets removed, becomes 1, and 32 becomes 2. So this fraction now becomes 2g16 divided by g8, which can be rewritten as 2g16 divided by g8. And since there's a rule for exponents that if we have xa divided by xb, this is always equal to x to the power of a minus b. So in this case, 2g to the power of 16 divided by g to the power of 8 is equal to 2g to the power of 16 minus 8, which is equal to 2g to the power of 8. This is your final answer for question 1, part A of question 12. Now note that for the exam you will have to memorize all these exponential rules, such as the one given above, since questions like these could occur where you have to make use of these exponential rules. Part B says to simplify 625 times k to the power of 8 and all that to the power of 3 by 4. So if you rewrite this as 625 times k to the power of 8 to the power of 3 by 4, the 3 by 4 acts independently on both of these terms, which means that this is equal to 625 to the power of 3 by 4 times k to the power of 8 by 3 by 4. And so for the left, this term, this is essentially equal to 625, like the root to the fourth of it, to the power of 3 times k, 8 times 3 by 4. This is because I'm making use of a second exponential rule, which is that if we have xa and this is to the power of b, this is equal to x by x to the power of a times b. So this rule is being employed here in this case. So on the left hand side, the root fourth of 625 is equal to, is equal to 5, and this to the power of 3 times k to the power of a times 3 by 4, which is equal to 6. So 5 cube is 125 and k6 is k6. Therefore your final answer is 125 times k to the power of 6. Question 13a says to shade the region A union B prime. So since we are shading the region A union B prime, in this case you can take U to be and or. This means that you can already shade the entirety of A without any repercussions, because union means that A will already be included no matter what. There's no parts of A that can be excluded from this region. And B prime says that alongside A, you should also shade the parts that are not in B. So since B is this outside, since B is this green circle over here, B prime is everything outside this circle. So this part over here. So if we combine these two, i.e. A and B prime, this means that, shade everything that's not in B. So everything outside is not in B, therefore that's shaded. And technically everything in A is also, most of A is not in B as well, except A intersect B. The rest of A is not in B, therefore that would be shaded too. But since it's already shaded because of A itself being in the equation, A union B prime, this means that you don't have to do that. It's basically twice shaded in a way. And this is your final answer for part A. For part B, it says, use set notation to describe the shaded region. I'll first write the answer before explaining why this is the case. The answer is equal to R intersect P prime intersect Q prime. So the reason that this is so is because intersect basically means and. So if you have two terms intersect, this means that both this condition and this condition have to be fulfilled. So in this case, since as we can see, a part of R is shaded, this means that R would have to be shaded in the first place. Since as you can see, part of R is shaded, this means that the entirety of R should have been shaded in the first place. And these parts of R, i.e. the part that intersects with P, the part that intersects with Q, and the part that intersects with both P and Q, these three get removed, such that only the yellow part that's still yellow is remaining. Which means that to remove all the parts of P that are intersecting with R, we have to do R and P prime. Which means that, so R minus P prime alone essentially means that all the elements that are in R and that's not in P. So this would represent all these terms. Since this part of R is also a part of P, which means that this is not included in the set notation R intersect P prime. And since this also says intersect Q prime, this means that not only is it asking for the elements that are in R and not in P, but also the elements that are not in Q. Which means that this region of R, which includes elements in Q, is also removed, since these are not counted. And so what we have left? We have One second. We have this region of R that's left, which is the shaded region. Therefore, the answer is equal to R intersect P prime intersect Q prime. Question 14 says P, Q, R, and T are points on the circle. AB is a tangent to the circle at T. Angle ADP is equal to 50 degrees. Angle PTR is equal to 48 degrees. And PQ is equal to QR. This point is important, PQ being equal to QR, since this means that since they have two equal sides, this triangle PQR is isosceles. So part A says to find the angle PRT. For this, we can just employ the alternate segment theorem, since if we have a tangent and a line made between a chord and a tangent, this essentially means that the angle that's opposite to this chord, so in this case angle PRT, which is what the question is asking for, this angle is equal to the angle made between the tangent and the chord. So in this case angle 50 degrees. So since the angle between the tangent AB and the chord PT is equal to 50 degrees, this means that the angle that's opposite PT, which is in this case angle PRT, is equal to 50 degrees as well. For more information about this, you can search up or watch videos on the alternate segment theorem for circles. Part B says to find the angle QPR. One second, let me first, So for this question, we have to make use of a different circle theorem, which is the cyclic quadrilateral theorem, which means that any two opposite angles for a quadrilateral, which in this case is PQRT, since it has four sides. So any opposite angles in a quadrilateral that's enclosed within a circle, these two opposite angles will always add up to 180 degrees, regardless of how long the sides are, regardless of where the sides are, and regardless of other angles. Opposite angles in a quadrilateral in a circle will always be equal to 180 degrees when added up. So in this case, since we have angle PTR plus angle PQR, which is this angle, plus angle PQR is equal to 180 degrees. Angle PQR is equal to 180 degrees minus the angle PTR, which is equal to 180 degrees minus 48 degrees, which is equal to 132 degrees. Now, if we have this final equation of PQR is equal to 132 degrees, I'll just write this on the top here so I can make use of the space below again. Angle PQR is equal to 132 degrees. Now, as you can see, the triangle PQR, as written before, is isosceles, which means that since we have the angle PQR and the angles QPR and QRP are the same because since two sides are equal, the base angles are also equal, since this is a rule of isosceles triangle. This means that to find the angle QPR is equal to angle QRP. One second, let me rewrite this because I think I wrote it very unclearly. Angle QRP and QPR plus QRP plus PQR is equal to 180 degrees. Since all the angles in a triangle, in this case the triangle PQR, all these angles add up to 180 degrees. And since QPR is equal to QRP, we can rewrite this as 2 times QPR is equal to 180 degrees minus angle PQR, since we move PQR to the other side. And so therefore, angle QPR is equal to 180 degrees minus PQR divided by 2, which is equal to 180 minus 132 divided by 2. Now, if I'll just move it here, this is equal to, this is equal to 48 divided by 2, which is equal to 24 degrees. This is your final answer for angle QPR. Question 15 says, the time taken for each of 200 students to complete a calculation is measured. The cumulative frequency diagram shows the results. Use the diagram to find an estimate for A, the interquartile range. So this question is basically saying that at any point on a curve, or on this curve, for example, at this point, the number of students that take equal to or less than this much time to answer the question is equal to 60, which means that as the time increases, the number of students that take this much time or less to do that question increases, because more students will take time between time A, let's take time 1 and time 2. More students will take time, at least 0 or more than 0 students will take between this much time to answer the question. Therefore, the cumulative frequency increases or remains the same as time increases. It can never decrease, because as the time increases, this increases the range of times that students have completed the work in. So the question A says to find the interquartile range. The IQR, the interquartile range, is equal to the value of the 75th percentile minus 25th percentile. Now to find the 75th and 25th percentile of 200, you have to do 75% times 200 for the 75th percentile, which is equal to 150, and 25% times 200, which is equal to 50 for the 25th percentile. So in this case, the IQR, so first the value of the 25th percentile would be equal to the time when the cumulative frequency is equal to 50. Since at that point, since 50 students would have taken either that much time or less, which means that the range of students, one second, let me first draw the line before I explain further. There we go. This means that if the point meets over here at 16, when t is equal to 16, sorry, there we go. Okay, yeah. This means that 16 students, like if the time is 16 or less, this means that 50 students have taken 16 seconds or less time to answer this question, which means that 25% of all students have finished the work in 16 seconds or less. That's half the question done. So IQ is equal to something minus 16. Now to find the 75th percentile, you have to see the time when the cumulative frequency is equal to 150. Since 150 is 75% times the total cumulative frequency, which is 200. So in this case, this is equal to, let me first draw 150 over here. Wait 1 second. There we go. 150 at this point. What happened? Okay, yeah. At this point over here, which when drawn again would be, 1 second, where did the rule go? Yeah, nope, that came off angled. It should be straight. There we go. This is equal to 27, which means that 75% of all the students have taken 27 seconds or less to finish the work, which means that most of the students would have taken 27 seconds or less to finish the work. And so the IQR is the number of students who is equal to the 75th percentile. Wait, out of 75th, I think the iPad corrected to 78th by mistake. I'll rewrite this as 75th percentile over here. Yeah, so the IQR is equal to the value when the cumulative frequency is at 75% minus the value when the cumulative frequency is at 25%. This is equal to 27 minus 16, which is equal to 11. So 11 is the IQR and that answers question A. Question B asks for the number of students taking more than 40 seconds to complete the calculation. This means that if I erase all this for simplification's sake, there we go. So question B says to ask for the number of students taking more than 40 seconds, so the keyword more than 40 seconds to complete the calculation. So if we draw a line for when time is equal to 40, and then draw the corresponding cumulative frequency when time is equal to 40, which is, as you can see, it's between these two lines over here. This means if we draw a line over here, no, yeah, and this means that this point is equal to 194. So this says that the number of students who have taken 40 seconds or less to finish the work is equal to 194. Since all these students over here that you can see, which keep adding up, the sum of all these students who have taken 40 seconds or less, i.e. 40 seconds or less, is equal to 194. And so the question asks for the number of students who have taken more than 40 seconds to finish their work. So this is equal to the total number of students minus the number of students who have taken 40 seconds or less to finish the work, which is equal to 194. So this is equal to 6. Therefore, your answer for part B is equal to 6. Question 16a says, to rearrange the formula, a is equal to pi r square plus pi dh to make h the subject. For these kind of questions where you have to change the subject, you have to make use of Grof-Groblet. Let me first write them down before I explain it. Sorry. Grof-Groblet. So Grof says to get rid of fractions. Grof says to get rid of brackets, and Let says to lump everything together. So in this case, we first check if there's any fractions in the question, since we do Grof first. As you can see, there are no fractions in this equation over here, therefore this is omitted. Next, you can see get rid of brackets. As we can see, there are also no brackets in this equation, therefore this is also omitted. Now the third part is let, lump everything together. This means that we put all the terms that do not have the variable that we want. So in this case, if the desired variable is h, this term has h and only this term, which means that we move all other terms to the other side. So in this case, the other term, pi r square, is moved to the other side. So the desired term, pi dh, which contains the term that the variable that we want, is equal to a minus pi r square. So h would be equal to, wait, so 1 second. If we divide both sides by pi d, this cancel off pi d over here, and this means that h is what's left on the left hand side over here. H is equal to a minus pi r square divided by pi d, and this is your final answer. H is equal to a minus pi r square divided by pi d. If there were fractions or brackets, we'd first try to remove them through multiplication and all that before we lump everything together. We move all the terms that have the variable that we want on one side, and all the terms that do not have the variable that we want on the other side. Question 17 says to work out giving each answer in standard form. Part A says 2.1 times 101 times 2.1 times 10 to the power of 101 times 8 times 10 to the power of 101. So if we break this down by removing all the brackets, this means that this is equal to 2.1 times 10 to the power of 101 times 8 times 10 to the power of 101. So if we see, we can multiply 2.1 and 8, which is equal to 2.1 times 8, 2.1 times 8 times, and we can take these two terms as well, times 10 to the power of 101 times 10 to the power of 101. Now, as I said before, if we have the same base, like xa multiplied by xb, this is equal to x by a plus b. Therefore, the green terms can be simplified as times 10 to the power of 101 plus 101. And the left term is equal to 2.1 times 8, which is equal to 6. 1 second, 2.1 times 8, 16.8. Now, since 16.8, it does not fit the standard form equation, since for standard form is equal to k times 10 to the power of n, where k is more than or equal to 1 and less than 10. Since 16.8 is more than 10, this means that we have to break down 16.8 into, 1 second, 16.8 is equal to 1.68 times 10 to the power of 1. Since we move this decimal place to one side when multiplying by 10 to produce 16.8. This means that 16.8 on the left hand side can be rewritten as 1.68, 1.68 times 10 to the power of 1 times 10 to the power of 101 plus 101. So this in turn would be equal to 1.68 times 10 to the power of 101 plus 101 plus 1, because as you can see the base is still the same. So the final answer is equal to 1.68 times 10 to the power of 203. So this is your part A answer solved. Let me just put like a line to separate these two questions. Part B says 2.1 times 10 to the power of 101 plus 2.1 times 10 to the power of 100. So as you can see, part B does not have multiplication like part A, but instead addition, which means that rather than just trying to multiply all the terms to get a final answer, we instead have to find the common factor of these two terms. So if term 1 is equal to 2.1 times 10 to the power of 101 plus 2.1 times 10 to the power of 100, we first try to find a common factor between these two terms. In this case, if we break down this into 2.1 times 10 to the power of 100 times 10, since as I said before, xa times xb is equal to xa plus b. Therefore, 10 to the power of 1 times 10 to the power of 100 is equal to 10 to the power of 101, which is on the left hand term. So, as we can see, 1 second, 10 to the power of 100 times 2.1 is also on the right hand side, which means that we can which means that we can take out this and put this into one side, 2.1 times 10 to the power of 100, and this times, so what's left on the left hand term is equal to 10, and what's left on the right hand term is nothing, so it's plus 1. Since this gigantic factor will act on 10 and 1 independently. When acting on 10, it produces the left hand term over here, and when acting on 1, it produces itself, which is the right hand term over here. Therefore, if we rewrite 10 plus 1 is equal to 2.1 times 10 to the power of 100 times 11, this would be equal to 2.1 times 10 to the power of 100 times 11. And now we can use the same thing we did in part A by multiplying these two, 2.1 and 11, i.e. the non-base 10, i.e. the numbers that are not in the form of an standard form. So this would be equal to 2.1 times 11 times 10 to the power of 100. And 2.1 times 11 is equal to 23.1 times 10 to the power of 100. And 23.1 can be rewritten as 2.31 times 10 to the power of 1 times 10 to the power of 100. And so as I said before, you can add 1 and 100 to get the final answer of 2.31 times 10 to the power of, times 10 to the power of 100 plus 1. So if I move this over here, this would be equal to 2.31 times 10 to the power of 101. That's your final answer. 2.31 times 10 to the power of 101. Question 18 says that the diagram shows two sides, VA and VB, of a regular polygon. A regular polygon means that all sides are equal and all interior angles are also equal. AVX is a straight line, angle BVX is equal to Y, therefore this, and angle AVB is equal to 11.5 Y. So like this. Find the number of sides of this polygon. For this, we have to make use of two rules to find the number of sides of this polygon. The first rule is a straight angle one, which means that all angles in a straight line add up to 180 degrees. So since there are two angles that make up a straight line in this case, 11.5 y plus y is equal to 180 degrees. And this is equal to 12.5 y. Therefore, y is equal to 180 divided by 12.5, which is equal to 14.4 degrees. This is the angle of y. Now, second one is harder to explain. As you can see, y is an exterior angle. Since if we redraw this, if we draw, for example, a regular hexagon, and we draw straight lines that continue out from each side, like this, there will be 6 exterior angles, i.e. the angle that is opposite to the interior angle. Since if we treat the interior angle as green, the exterior angle is the angle that's opposite to it, i.e. the angle that when added to the interior angle makes up 180 degrees. So each of these exterior angles, the sum of all these, will always be equal to 360 degrees, regardless of the number of sides, which means that if we have the length of the angle of one exterior angle, which is in this case 14.4, and multiply by n, where n is the number of sides, this will be equal to 360 degrees. Since in this case, if each exterior angle is equal to, for a hexagon in this case, if each exterior angle is equal to 60 degrees, 360 divided by 6. If each exterior angle is equal to 60 degrees, when added 6 times, they will add up to 360 degrees, which means that the sum of all exterior angles of any polygon will always be equal to 360 degrees, which means that if you have the value of one exterior angle, that value of that one exterior angle times n, where n is the number of sides, would always be equal to 360 degrees. Since if you have, for example, in a pentagon, if you have 5 exterior angles and the length of one is equal to 72 degrees, this means that the sum of all the exterior angles is equal to 72, which is the angle of one exterior angle, times 5, which is the number of sides, and also equal to the number of exterior angles. This would be equal to 360 degrees. Therefore, n, which is the number of sides, is equal to 360 degrees divided by 14.4, and this is equal to 25. To re-explain this one last time briefly, the number of sides in a polygon will always be equal to the number of exterior angles, which means that if you have the length of one exterior angle, i.e. the angle of one exterior angle, and you want to know how many exterior angles there are, this means that one exterior angle added up n number of times would always be equal to 360 degrees, where n is the number of exterior angles, and since the n would also be equal to the number of sides, since the number of sides is equal to the number of exterior angles, this means that if you divide 360 by the length of one exterior angle, you get the number of exterior angles, which is equal to the number of sides of a polygon. Question 19 says, part A says to describe fully the single transformation that maps triangle T onto triangle W. As you can see, if this is triangle T and this is triangle W, there's a rotation occurring. In this case, this is a rotation by 90 degrees clockwise, since it's only rotating 1/4 of a full circle, which is 360 degrees. So for this 3-mark question, for 2 marks, you have to first write rotation. I'm writing comma in this case, 90 degrees clockwise. You can also write it as 270 degrees counterclockwise, since as you can see, 3/4 of a counterclockwise rotation will produce W as well. Therefore, anything equivalent to 90 degrees clockwise is acceptable based on the mark scheme. And the third part is the hard part, since the third part is to find the center of rotation, since that is what gets you a third mark in this 3-mark question. For this, if you don't have tracing paper, you have to use the steps below. And if you do have tracing paper, I recommend you watch a video on how to use tracing paper to find the center of rotation for these kind of questions. If you don't have tracing paper, you take any 2 points, corresponding points of the triangles, and you draw a line segment between them. So in this case, I'll just erase these points to make it clearer for me, since iPads are really hard to draw, to be honest. Nope. 1 second. Nope. Almost there. There we go. So this is a line segment 1 for 2 corresponding points. And if you take one more line segment for a second pair of corresponding points, in this case, I'll take this one over here and this one over here. Make sure that they are corresponding, and do not just take 2 points that are not corresponding. So if we take these 2 points and draw a second line segment that passes through both of them, let's see. I'll erase these again, like I said before, for convenience sake. There we go. So that's the first part done. The second part is to find the perpendicular bisector of these 2 line segments, i.e. you first find the center of these 2 lines by measuring the length of these 2 lines and dividing that by 2 to find the center of these perpendicular bisectors. So in this case, we might have it over here. Then after you have the center figured out, so for now I'll estimate the center as over here, this red point. You then draw a line that's 90 degrees to the line itself, like the line segment itself. So in this case, actually I think I messed up the angle, the point. It should be somewhere closer to here. Okay, 1 second. There we go. So this is the first perpendicular bisector, and you draw it like fully, like you don't draw it to any limits, you just draw it to the edges of the graph. 1 second, almost there. There we go, you draw it to the ends of the graph. Then for the second line segment, the second yellow line, you do the exact same thing again. You try to draw a perpendicular bisector of this line. So if I estimate, for example, that the center of rotation, that at the middle point, the midpoint of this line segment is here, for instance. This is an estimate again, like I said. The perpendicular bisector would pass like this. As you can see, the two perpendicular bisectors of these two line segments that join two corresponding points on the two triangles, single point where the two perpendicular bisectors meet is at 0, -2. So this is the center of rotation. So for the third point, I'll write rotation around, not around, I'll say about center, then bracket, because it's a point, 0, -2, since that is the coordinates of the point. That is your 3 points for the part A. Part B says to draw the enlargement of triangle T with scale factor -2 and center of enlargement -1, 1. So I'll first erase all these marks I've done before from part A. So part B is asking for you to draw the enlargement of T with scale factor -2 and center of enlargement -1, 1. So I'll first draw the center of enlargement, which is over here, and -1, 1. Sorry about that. Anyways, so to find this enlargement by scale factor -2, there are many methods. So I'll just give you my method for now. So you first find the distance between any one of these points and the center of enlargement. So in this case, it is 1 down and 2 to the right. So you then repeat this 2 times. 1 down, 2 to the right, 1 down, 2 to the right. You repeat this twice because the enlargement is by a factor of -2. If it is by -3, you'd repeat it 3 times. If it is by -1/2, you'd repeat it half the times. I just take half the distance that goes down and the distance that goes to the left, and so forth. So this is point 1. Now for point 2, if I make it yellow this time instead, the distance between the yellow point and the center of enlargement is 1, 2, 3, 4 down, and 1, 2 to the left. So if I repeat this 2 times, 1, 2, 3, 4 down, 1, 2 to the left, 1, 2, 3, 4 down, and 2 to the left. This is the second point. Now the third point, which I'll mark as green, the distance between this and the center of enlargement is 1, 2, 3, 4 down, and 1, 2, 3 to the right, 3 to the left, sorry. 1, 2, 3, 4 down, 1, 2, 3 to the left, 1, 2, 3, 4 down, 1, 2, 3 to the left. This is the position of the third point. Now that you have the 3 points of the triangle, as you can see down below, you can now draw 3 lines that connect these 3 points to produce the enlargement of triangle T by scale factor -2 about center -1, 1. Nope. This is a rough approximation since, like I said many times, it's hard to draw with an iPad. I hope in the exam you can do better with a sharp pencil and a ruler. There we go. So this is the enlargement of triangle T by scale factor -2 and center of enlargement -1, 1. You can see that this is likely to be right because the triangle is inverted. Since when the scale factor is negative, the triangle gets inverted, and when the scale factor is positive, the triangle remains in the same upright position as it was before. If I wanted to do scale factor +2 instead of scale factor -2 for the same question, if I had center of enlargement over here, and I wanted to find the new position of the red point over here, Rather than go from the red point to the center of enlargement, I'd go in the opposite direction. I see the distance between the center of enlargement and the red point. So in this case, 1, 2 to the right and 1 up. And I repeat that 2 more times. 1, 2 to the right and 1 up. Wait, sorry, I repeated only one time. My bad. Then I do the same thing for the other 2 points. And I connect the 3 new points that I formed, and then I to make a new triangle. That's question 19 solved. Question 20a. Fx is equal to 3 to the power of x plus 2. A says to find x when fx is equal to 245 degrees. So for this, since fx is just equal to 3x plus 2, I'll replace fx with 3x plus 2. Sorry, 3 to the power of x plus 2. And this is equal to 245. So if I subtract both sides by negative 2, this produces 3 to the power of x is equal to 243, which in turn is equal to 3 to the power of 5. So since 3 to the power of x is equal to 3 to the power of 5, if I remove 3 from both sides, this means that x is equal to 5. So that's part A solved. I think since the part of this answer is blocking part B as it is this for now, there we go. Part B says to find x when f inverse of x is equal to 7. For this question, I'll employ a simple rule, which is that f, the composite function of f and f inverse of x is always equal to x, regardless of what the function is. So which means that if I replace f minus 1x with 7, since f minus, sorry, not f minus 1, if I replace f inverse of x with 7, since it says in the question that f inverse of x is equal to 7, this means that f7 is equal to x. And so if I replace 7 with the x over here, this means that 3 to the power of 7 plus 2 is equal to x, which is equal to 2187 plus 2, which is equal to 2189. That's your answer for part B. Second, 2189. Okay, there's no more dots. That's perfect. Question 21 says to write the recurring decimal 0.41, where 1 is the recurring digit, as a fraction in its simplest form, and you must show all your working. So if I substitute like x to be the variable that represents 0.41, where 1 is recurring, this is equal to 0.4111 dot 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 so forth. Now, since if x is equal to 0.4111 so on, 10x would be equal to 4.111 so on, since it's equal to 10 times 0.4111 so on. And so 4 gets moved out to the left of the decimal point, and the ones get pushed up by 1 position. And so if we do 10x minus x, this is equal to 4.111 dot 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 minus 0.4111 dot dot dot. And so this is equal to, if I just take the first 3 decimal places, minus 0.4111, since any subsequent ones will anyways get cancelled off, since it goes to infinity, this goes to infinity, and they cancel each other off. Therefore, I'll only take a few decimal places just in case. So this is equal to 1 gets cancelled off, 1 gets cancelled off, 0, 0. 1, this becomes 11 since this is basic grade, like primary school subtraction. 4.1 minus 0.4. This 11 minus 4 is equal to what? 7, and 4 becomes a 3, 3.7. Therefore, 9x is equal to 3.7. Therefore, x is equal to 3.7 divided by 9. Let me first erase this working over here. So x is equal to 37 by 90. Now, the answer said to give your answer as a fraction in its simplest form. And since 37 by 90 cannot be simplified any further, since they have no common factors, this means that the final answer is 37 by 90. Note that if there were 2 recurring digits instead of 1, since here we have 1 recurring digit, if there were 2 instead, you'd use 100x instead of 10x, and you'd use 99x here instead of 9x. And if there are 3 recurring decimal digits, instead of 10x, you'd use 1000x, and instead of 9x, you'd use 999x. But the steps otherwise remain the exact same. You try to subtract 10x or 100x or 1000x by x to get the value of 9 or 99 or 999x, and then divide the value that's produced by 9 or by 99 or by 999 to get the value of x in itself. Question 22 says to solve the equation tan x plus root 3 is equal to 0. So if I rewrite this as tan x plus root 3 is equal to 0, and I subtract both sides by negative root 3, this means that tan x is equal to negative root 3. So when tan x is equal to negative, the value of x, there are two possible values of x. It's either 180 degrees, 180 degrees minus tan inverse of the positive value of this thing over here. So in this case, that's equal to positive root 3, or it's equal to 360 degrees minus tan inverse of the same thing, of positive root 3. You ignore the negative sign in this case. So the two values of x are exactly 120 degrees and 300 degrees. So for the reason why that we use these two specific rules, I'll take 2 minutes to explain this right now. If we try to draw a graph of all sine, tan, cos, and we write rules, corresponding rules for this. This is the inverse of y. This is 180 degrees minus the inverse. I'll make it shaded. Inverse of y. This is 180 degrees plus the negative inverse of y. And cos is equal to 360 degrees minus the inverse of y. But y is equal to the positive value of this number over here, of like the other side. So to get the value of x for any of these things, you first see, let's take our equation tan x is equal to negative root 3 as an example. Since tan x is negative, we take the two sides where there's no tan at all. Since all basically means sine, cos, tan, this means that tan is over here and is over here. So we ignore those two sides and take the other two sides. So in this case, we take sine and cos and use their corresponding rules. So 360 minus the inverse of the y, which is the positive value of the negative tan x, and we take the sine rule, which is 180 degrees minus the tan inverse of the positive value of root 3. If it was sine x is equal to negative root 3, we'd instead use the rules of tan and cos. So sine x is equal to negative root 3. The value of x would be equal to 180 degrees plus sine inverse of root 3 and 360 degrees minus sine inverse of root 3. And the same thing applies for cos. If cos x is equal to negative root 3, we do 180 degrees minus sine cos inverse of root 3 and 180 degrees plus cos inverse of root 3. Since we use the rules of sine and tan, so these two rules. Question 23 says to simplify 2 divided by y plus 1 minus 3 by y. So if I rewrite this over here, 2 by y plus 1 minus 3 by y. To make it a single fraction, you have to first multiply the numerator of the left fraction by the denominator of the right fraction. So this is equal to 2 times y. Then you see the symbol that's between the two fractions. In this case, it's a negative. Therefore, you do negative of, then you multiply the denominator of the first fraction by the numerator of the second fraction. So this is equal to 3 times y plus 1. Then that's our numerator for the single fraction. For the denominator, you just multiply the two denominators of the two fractions. So in this case, y by y plus 1. So if we simplify this, this is equal to 2y minus 3y minus 3 is equal to y by y plus 1, which is equal to negative y minus 3 by y plus 1. This is the final answer. Obviously, you can simplify this further by doing, if you move the negative to the left hand side and write y plus 3 by y plus 1, or if you expand y by y plus 1 to get y square plus y, that works since the mark scheme has many different possible answers. So the final answer, for my case, I'll write it as negative y minus 3 by y plus 1. Question 24 says that the diagram shows a triangular prism with cross-section triangle BCV. Angle BCV is equal to 90 degrees, BC is equal to 5 centimeters, CV is equal to 4 centimeters, and AB is equal to 15 centimeters. Calculate the angle between AV and the base ABCD. In this case, for the base ABCD, it is a rectangle. Therefore, all these angles are right angles as well, which is important for later. Since the question is asking for an angle between AV and the base ABCD, this means that we can take any line in base ABCD, and if we connect that to AV and V to the point, we can produce a triangle. So in this case, if I take, one second, let me erase these. If I take AC as a line, this is a line in the base ABCD. If I connect CV and I connect AV, I have a new triangle, since a triangle is straight lines between any 3 points, and I have my 3 points AC and V. So if I redraw this triangle, A, C, V, where AC is equal to the base, and this is a right angle, as you can see, since it's given in the question that angle BCV is equal to 90 degrees. Therefore, angle ACV is also equal to 90 degrees. So the length of CV, as written before, is equal to 4 centimeters. So to find the angle between AV and the base ABCD, I'll let this angle as X for now. One second. I'll use a different color to make it more significant. Angle X between AV and the base ABCD essentially means between AV and any line in the base ABCD, as long as the other point that's not A and not V is also connected to V. So in this case, I took the point C, since that is the simplest point in this case, as you can see later. So to find this angle X, you can either find the length of AV or the length of AC, and then use trigonometry, i.e. sine inverse, cos inverse, or tan inverse, depending on what you find, either the hypotenuse or the adjacent. But actually, in this case, you would not be able to use the cos inverse, since the opposite will anyways be involved. Since the opposite is equal to 4. So in this case, I'll find the length of AC. So as you can see, in a separate triangle, AC, CV, and AB are also connected. And since ABC is 90 degrees, because the base is a rectangle and all rectangles are 90 degrees, this means if I draw a new triangle, triangle A, C, B, and if CB is equal to 5 and AB is equal to 15, we can use the Pythagorean identity, where A square plus B square is equal to C square. Therefore, 15 square plus 5 square is equal to C square, which is equal to 250. Therefore, therefore AC, which is the hypotenuse over here, I C for now, AC is equal to the root of 250. So if I sub in the root of 250 over here, and I erase this triangle over here and all this working, obviously like in the exam you shouldn't erase your working, you should show as much working as possible for the examiner to not cut marks, since any working steps could count for any marks potentially. In this case, I'm erasing my working so that I have space for subsequent workings. So since for any right angle triangle, if you have the angle this, the opposite is the angle is the opposite is the side that's opposite to the angle. Then you have the adjacent, that's the non-hypotenuse side that's touching the angle, and hypotenuse is the side that's opposite to the right angle and the longest side. So since we have 4, which is the opposite, and we have root 250, which is the adjacent, to find X we have to use, let's first reference TOA. We use TOA because TOA has both O and A, and those are the two sides that we have. So in this case, if we write tan X is equal to the opposite by the adjacent, since in TOA O comes before A, therefore O is the numerator and A is the denominator. This is equal to 4 by root 250. Therefore, the value of X is equal to tan inverse of 4 by root 250, which when rounded to 1 decimal place, since for any angles that are not precise, for example 19.2222345, you have to round it to 1 decimal place regardless of how many significant figures there are. So in this case, this is equal to, one second, let me just do it, tan inverse of 4 by root 250. This is equal to 14.196947 ... But always round to 1 decimal place for any non-precise angles. Therefore, this is equal to 14.1 as a final answer. No, sorry, 14.2, my bad, because 9 is more than 5, therefore 1 gets added and the rest get removed. So 14.2. Question 25 says to simplify pt minus p minus t plus 1 divided by 1 minus t squared. So if we rewrite this as pt minus p minus t plus 1 by 1 minus t squared. For the numerator, as you can see, pt minus p has a common factor of p. Therefore, we can rewrite this as is equal to p times t minus 1, since those are the terms that are left. If you remove p from both pt and from negative p, then on the other side we have negative t plus 1. So I'll just group this as well, t plus 1. 1 second. Sorry, it should be t minus 1 over here because two negatives make a positive. Therefore, if we combine these two, this makes it plus 1, and negative t is negative t. This is equal to the right side over here. So p times t minus 1 minus t times t minus 1, then this is divided by the denominator of 1 minus t square. So since both these values, since both these values are the same, we can take the outside coefficients, in this case p and negative 1, and we can put that as a new group altogether. So p minus 1 by t minus 1 minus 1 minus t square. This is because if we have a by x minus b, for example, minus c by x minus b, this is always equal to a minus c by x minus b. This is essentially a rule that you have to memorize or understand conceptually in order to be able to answer such questions in examinations. So that's the numerator that's factorized. Now for the denominator, 1 minus t square, we use the a square minus b square is equal to a minus b by a plus b rule for in this case. This is also a rule that you have to memorize for the exam. So in this case, 1 minus t square, since a square is equal to 1, a is also equal to 1, and if if b square is equal to t square, b can be treated as t. So 1 minus t square is equal to a minus b, which is 1 minus t by a plus b, which is 1 plus t. Therefore, we can rewrite this fraction as p minus 1 by t minus 1 by 1 plus t and 1 minus t. As you can see, t minus 1 and 1 minus t are almost the same, except it just the negative signs are swapped. So in this case, t is positive in the numerator and negative in the denominator, and what is negative in the numerator and positive in the denominator. So to correct this, let me first erase this and make these terms the same. We can multiply negative 1 in both sides. So if we do p minus 1 by t minus 1 times, times negative 1, and for the right side we can do 1 plus t 1 minus t times negative 1. So since the negative 1 acts on the 1 minus t, we can take any one of these two sides. You can either make it act on t minus 1 or on 1 minus t, but not on both. If you make it act on, for now I'll use the denominator side. So if we do rewrite this as negative 1 times p minus 1 times t minus 1 divided by 1 plus t by t minus 1, because the negative 1 acts on the t minus 1 minus t. Therefore, this negative 1 times 1 becomes negative 1, and negative 1 times negative t becomes positive t. T minus 1 is equal to negative 1 times t. And so since these two terms are now the same, they can be cancelled off. So this is equal to negative 1 by p minus 1 by 1 plus t. And so this negative 1 acts on both the p and the negative 1 to produce the final value of 1 minus p by 1 plus t. This is your final answer. 1 minus p by 1 plus t. Question 26 is your final question, and and it says that in a diagram, O is the origin, OP is equal to P, and OQ is equal to Q. R is the point of intersection of PQ and OS, with PR is equal to RQ, with PR to RQ is equal to the ratio of 1:2, which means that if we take PR over here, this length and this length and this length are all the exact same, since two PRs will fit into RQ. So OR is equal to RS, which means that if you take this, this length is equal to this length, it's exact same. So the question is asking you to find the position vector of S. The position vector of anything means the position of S relative to O, which means OS in this case. So the position vector of P would be OP, the position vector of Q would be OQ, and the position vector of R would be OR. Since it's asking for the position of the thing relative to O, i.e. the origin. So in this case, the position vector of S is equal to OS, and as you can see, OS is equal to 2 times OR. This is because if OR is equal to one of these units, one second, sorry. If OR is equal to one of these units, OS is equal to 1 plus 1. So 2 of these units, since it's twice of OR. Okay. Now with that done, we should now find what length of OR is. As you can see, OR is equal to, wait, let me erase all these workings, I guess, for a clean slate in this case. The goal to find OR, we can see that OR is equal to OP plus PR. Since we can take any route to get to the same position in end, and the value will always remain the same. So you could do OQ plus QR or OP plus PR, and the value should always remain the same irregardless. So OR would be equal to OP, one second, I think it's getting erased, OP, this is weird, OP plus PR. There we go. Now to find PR, as told in the question, the ratio of PR to RQ is equal to 1:2, which means that PR to PQ is 1:2 plus 1, which is equal to 1:3. Therefore, PR is equal to 1/3 of PQ. Like the vector of PR is equal to 1/3 of the vector of PQ. So OS is equal to 2 times OP, which is just P. Since I said in the question OP is equal to P, plus PR, which is equal to 1/3 of PQ. Now this is equal to 2 times P plus 1/3 of PQ, which is PQ can be rewritten as, and I'll use yellow in this case, PO plus OQ, since that is equal to PQ. So PQ is equal to, PO plus OQ. So OS would be equal to 2 times P plus 1/3 of negative P plus Q, since that's PO is equal to negative P. If OP is equal to positive P, PO is equal to -3, since it's just the negative value of OP. And OQ is equal to Q, as said in the question before. So OS is equal to 2 times, one second, P minus 1/3 of P, which is equal to 2 by 3 P plus 1 by 3 Q. So if you multiply 2 by 3 P and 1 by 3 Q by 2, this is equal to a final answer of 4 by 3 P plus 2 by 3 Q. This is the final answer over here. Wait, I think the 4 is not very clear, so I'll rewrite that. 4 by 3 P plus 2 by 3 Q. Thank you so much for watching, and I hope you can subscribe to my channel and like this video and comment any questions that you might have about this paper or any other papers.